Hi everyone, today we're going to talk about asymptotes. Now, first of all, you have to know that we have two types of asymptotes. We have the vertical asymptote and the horizontal asymptote. Now, first of all, you have to know the main difference between both vertical asymptote and the horizontal asymptote. Now, from the word, by saying vertical asymptote, it is a vertical line. And by saying a horizontal asymptote, it is a horizontal line. Now, to understand what does the word vertical asymptote means, let's take a function as f of x equals 1 over x. Okay? Now, let's do graph for this function, first of all, just to understand what does vertical asymptote means, or asymptotes in general. Now, to do graph on Casio CG50, you have to choose option number 5, which is a graph. So press on F5. Okay. Here is F5. And write your function right now. It is 1 over x. Then put equal, then put fx, which means draw. Now here is the function. All right. Now, as we say that if you want to understand exactly what does the word vertical asymptote as we draw it on the graphing calculator, let's say that we want to draw it again on this board, which is like this. Here's the y-axis, x-axis. Here's the graph of 1 over x. I mean the function f of x equals 1 over x. Now I'm going to ask you a question. What will happen for the function f of x when the denominator is equals to 0? I mean, when x equals to 0. Now, when x equals to 0, we're going to get the value 1 over 0, which is not accepted by doing mathematics. I mean, you're going to get no value, all right? Because the function f of x is undefined when the denominator equals to 0, because in math, 1 over 0 is undefined value, all right? Now, by saying undefined value, I mean there is no specific point on the y-axis. So we have nothing on the y-axis, all right? Now, we can do an expression to express this nothing on the y-axis by this dotted line. And what do we call this line? Vertical asymptote. So that's the definition of the vertical asymptote. Now, what about the horizontal asymptote? Now, by saying the horizontal asymptote, we're talking about the value of the function, all right? The value of the function when the x value goes to infinity or negative infinity. I mean, again, it is the value of the function when the value of x getting greater and greater or getting smaller and smaller. That what do we call it, or what do we mean by saying horizontal asymptote? Now, to understand this, I'm going to give you an example, but we're going to go through specific details for the horizontal asymptote because it takes more than one probability to understand the question or to solve any question refers to the horizontal asymptote. But now we're talking about the definition, all right? So let's say that we have the same function, I mean f of x equals 1 over x. I'm going to draw it again, and we did it using the calculator, and I mentioned the steps. So let's say this is the graph of 1 over x. Now, from the definition that I said it for the horizontal asymptote, what will happen for the function f of x as x getting greater and greater? As x getting greater and greater, I'm talking about going as possible as to the right as we can, all right? And as positive as possible as to the left as we can, okay? So it goes to infinity or minus infinity, the function itself. So when the function is going to infinity or minus infinity, or when x is getting greater and greater, and x is getting smaller and smaller, okay? So, what will happen for the function when x getting greater and greater? It being very close from the x-axis. From this side, and the side. What does that mean? Being closer and closer from the x-axis. It means getting closer and closer from 0, all right? I mean, because the x-axis has an equation y equals to 0. That's why. And we talked about that, by the way. So what will happen for the function when x is getting greater and greater, the value of the function is getting closer from the 0, all right? So what is the horizontal asymptote? As y equals 0, okay? So when x is getting greater and greater, y looks like approaches the x-axis, which means y equals 0. And where x is getting smaller and smaller, as well as getting smaller and smaller, I mean y to touch the x-axis, which means y is equals to 0. Now, to get more understanding about the horizontal asymptote, look at this graph. X is getting greater and greater, and y is getting very close from the x-axis here on the graphing calculator, from the right side, which is positive infinity, from the negative side, which is negative infinity. So while you are studying the horizontal asymptote, you have